So today I'm going to talk about reproducible builds, what it is, why I think you should care, and why I think it's great. So, of course, my remote's also not working. There we go. All right. So most of the time, whenever we talk about security, there's this feeling that productivity will decrease, right? Whether it's running vulnerability scanners, static analysis tools, whatever those things are, nobody gets excited when somebody introduces a new security tool, except for the people introducing that tool. Now, I feel like there's other ways to mitigate these issues, but the first thought people have are something's going to be slow, right? So that's why I'm excited about reproducible builds. So I think reproducible builds are probably the first security practice that I've heard of that actually has the potential to make your builds faster. All right, so I'll tell you a little bit about me before we get started here. So I'm Brian Demers. I'm a developer advocate at Gradle. So I've spent a lot of my career in and around various open source communities, specifically in the Java world, in the areas of application security and build tools. Now, I always say the same story, but it's basically those two things seem like opposite ends of the spectrum, right? What do build tools have to do with application security? Well, as soon as you start publishing packages to Maven Central or downloading packages from your internal Maven repository or whatever it is, you realize there's some security involved there, right? You need to authenticate with servers. So anyway, that's how I got involved with both of those worlds, working on build tools and servers for related to build tools. Outside of all that, at home, I live in New Hampshire, probably, I don't know, an hour and a half or so north of Boston on the east coast of the States. And I play a lot of board games when I'm not working. And I also have bees in my backyard. So I have 3 hives right now. They're all buttoned up for the winter, but I did get a bit of honey this year, so I was pretty excited about that. All right, so I don't know how this is going to work virtually. I haven't tried this out virtually yet, but bear with me. So let's play a little game. So let me know in the chat which one of these you're going to pick. So if you're a fan of tabs, write tabs in the chat. And if you're a fan of spaces, write spaces. So if nobody responds, I'm just going to assume everybody's a big spaces fan like me. Although so far it's only been tabs people. So I need my spaces people to answer here. All right, so we'll do another one of these. You can argue about this the rest of the conversation if you want, but we'll do another one. So dogs and cats. All right, so I guess technically you could be a fan of both of these things, but over on the side here, this is my dog Zemo. He's about 2. He's like 100 pounds or I don't know, not quite 50 kilo. And this is just some random cat video, a cat picture I found on the internet. So, all right, the dog people are coming in the chat here, so I appreciate that. All right, and of course, I don't know if you saw this coming, but now build tools. Okay, so what's your favorite build tool? Right? Is it Gradle build tool or is it Maven? So you can actually be a fan of both, but most people are gonna have one that they choose. So if you were paying attention to my bio slide, you probably noticed that Maven was prominently featured, but I work at the company Gradle, right? So this is not a talk about Gradle, but there's this elephant in the room that I want to clear up, right? So I work for the company Gradle. Gradle created Gradle build tool, which is typically what we think about when you hear the term Gradle. We also have a product, Develocity, that's all about making your builds faster, whether it's Gradle build tool, Maven, Bazel, or SBT. I work kind of on the Develocity side of the house, and I like to talk about Maven a lot. So anyway, so that's why a Maven fan is working at Gradle. But long and short of it is we don't care which build tool you're using as long as you're productive. And I'll talk a little bit about productivity at the end here. But what we're going to talk about today, specifically reproducible builds, what it is, why I think you should care, right? And then, as I mentioned, I'll talk a little bit about developer productivity, how are those two things related, specifically around the areas of build cache, and hopefully along the way, I'll give you a couple tips and tricks. All right, so if you have heard of reproducible builds before, let me know in the chat. I'm going to assume most people haven't because that seems to be the way of the world. It's still relatively new. But reproducible build is not a tool, which is, I think, part of the problem. It's a set of practices. Now, the practice is it's a set of practices that allow you to create an independently verifiable path from source to binary. Now that's a mouthful. I'll explain what all that means in a few minutes. But if you haven't checked it out, check out reproduciblebuilds.org. It's a great resource. If you're not in the Java world, they probably have a language, a guide for your language of choice and your tools of choice. At the end of this talk, I'll have a QR code that you can scan to get all the links that I talk about and a bunch of other stuff. So don't worry about, typing things out as we go. I'll get you a link to the slides afterwards. Okay, so reproducible builds. What does this mean? What does this independently verifiable path from source to binary mean, right? So in a nutshell, if you and I both build the same code from source, we want to get the same results, the same exact results, right? That way I know you didn't put anything malicious in your build, and I didn't put anything malicious in my build, right? Our builds need to be deterministic, right? You build something twice, you get exactly the same bits. Hopefully everyone knows what a hash function is. If you don't, I'll go over it really quick here. So it's a one-way cryptographic function. You put data in, you get data out, right? The same data goes in, the same data comes out. Usually this is formatted as a hex string. You've probably seen this, but basically if I hash the results of my build and you hash the results of your build and we get the same hash value, then we know those files are the same, right? So this is the exact same principle that's used when you validate a hash after you download a file off the internet. Now, I know very few people who actually validate hashes after they download files on the internet, but that's a whole other conversation we could have. All right, so how do we get here, right? So why am I talking about this? Why aren't builds reproducible from day one, right? I think in the Java world at least has a history of non-reproducible builds, and there's no malicious intent there. It's just kind of how things happened. Most Java projects that I know of are packaged typically in some form of zip file, right? Wars, jars, ears, or literally zip files or some other package format, right? That archive, again, it's a zip file. It can contain whatever I want, but it usually contains some kind of metadata, right? So I'm going to pick on this old jar from Maven Core from 2009 for a minute. The focus here was on traceability and accountability, right? We wanted to know the who, right? Who built it, the exact version of Java that was used, sometimes the date. This file doesn't have a date in it, which is great, but sometimes they had dates in them. So if I look at this metadata, I know, I've opened this jar up, I've looked at the metadata file. I know John Casey was the release manager for this build, and he happened to use Java 142. Right, this was years ago. So this is great. This is nice information to have, but it would be really easy to fake this data, right? Or I could just open this jar up, put some extra stuff in there, zip it back up, and then you don't know that I'm not John, or maybe I can create a build tomorrow that I pretend to be John. There's other ways to check that type of assertion, right? You can check the signature of the file, a PGP signature, right? Or maybe my machine's compromised, or John's machine is compromised, and someone has access to my keys. I don't know, but anyway, having this data in the files aren't actually doing us a lot of benefit. So fast forward to today, or this summer, is when I grabbed this info. So here's a more recent version of that same artifact, right? And it basically just contains the bits that matter. So all we care about here is that Java 17 was used, and just the major version, right? Every major version of Java should build the same as any patch releases within that version. Now, there may be some edge cases there, but that's the idea. So any version of Java 17 should produce the same bits. All right, but why should we care, right? Some of us are thinking, maybe, of course, I want my build to be deterministic, right? Or integrity, right? Integrity means intact, or the lack of corruption. So we want to have our builds to have some integrity. So reproducible builds means you can verify the integrity of our software, right? Again, we want to make sure you didn't inject anything malicious in the build, intentionally or unintentionally. Hopefully everybody has heard of supply chain attacks. So we need some way of ensuring our bits are safe. So let's pretend my machine has been tampered with somehow, right? Maybe somebody had direct access to my machine, or maybe there's just a supply chain issue, right? I downloaded something else that was vulnerable. Now, I'm guessing everyone's going to say no, but if you've ever heard of the Xcode Ghost, this was a supply chain attack that a version of Xcode was distributed in China, right? And a bunch of people downloaded it, mostly because of the slow internet connection from the States to China, right? You have to go halfway around the world. Now, so what somebody did is somebody took advantage of this and put a version of Xcode with some malicious software in it. And this apparently affected over 4,000 different applications were published using this version of Xcode, and they injected some malicious code in there. Now, not all of those applications were built in China. There's elsewhere too, but it just happens to be, again, somebody took advantage of a slow internet connection and somebody's desire to download things a little quicker. All right, so how do you know the tools or the compiler you downloaded doesn't have some sort of malicious software in it, right? Right? Reproducible builds is one way to help us with that. So there's a whole conversation we could have about trusting your supply chain. You know, where did you get your compiler? Was it from some internal server? Well, where did they get it from, right? You know, turtles all the way down, maybe. But yeah, the idea is I could replace the real compiler with the evil compiler or something else, right? So I'll talk about zip slip here. So the bottom one, you know, the actual unzip command isn't vulnerable to path traversal attacks, but many unzip libraries are, right? So in the Java world, if you're using unzip library, you can actually extract files into places where they shouldn't be, right? So we're basically traversing outside of the zip. And I could overwrite files. You know, this is a silly example, but I'm going to override the password WD file. Now, many of our third-party tools are just downloaded from the internet from somewhere, right? I don't know, brew install, or who knows where you're getting your files from, right? So, or those things may not be compromised directly, but an attacker takes advantage of some other vulnerability or some other compromised dependency, right? So we need to watch out for these things. Okay, so who should care, right? I think we should all care. But I think, as always, I think open source software is kind of lead the charge, right? As consumers of open source, we also want to make sure that the bits we're consuming are the correct bits. So we should care as consumers of open source that those things are reproducible as well. But in general, I think every developer wants to work on a predictable system, right? The more things that change between two builds, it means the more chances there are for bugs to arise, right? We also want our users to trust the software that they're using. So you could take any project that you work on and you could include a verification step in your release process. So maybe you're doing your official builds on CI. So after you get your official build done, that's great. Then you take that same source and you build it on your laptop. If you get this same exact bits, then you know your CI system hasn't been compromised, right? And now there's a little more trust in that build that you're shipping. Okay, so, or maybe you're thinking, shouldn't all builds just be reproducible? Shouldn't just be how we do things all the time? Well, yes, but no, right? So in practice, this isn't always the case. There's often some form of entropy in our builds, okay? Being aware of this is half the problem. So I'll talk about some common examples. Okay, so dates. Dates are at the top of my list of being things that are a pain in the ass. So if you have never fixed a date-related bug, let me know in the comments. I probably won't believe you, but you can still let me know in the comments. Okay, so dates find their way in our builds, right? Sometimes it's metadata, like I talked about before. You just have some file like, oh, this thing was built on Tuesday. I don't know. Or the date formats. Maybe you have a constant date, but the format changes, or the locale changes, which changes how the date looks, right? I'm in the Eastern time zone. So if I format my dates using time zone specific formatting, or things are going to look different on someone else's machine. Or we often stick dates in our versions, right? And that has potential problems. So specifically related to versions, if you run a build and your version is just the current time you're running your build, that could be a problem, right? Because the next time someone comes along and runs that build, the date's going to be different. So those things need to be deterministic. So one way around that is instead of grabbing the current date, you grab the date of the last modification from your source control. All right. So dates of your files matter too, and this gets a little tricky. Okay, so if I have a build and I create a file, right? So here's a jar file. The date here is the date on my file system, right? So my operating system is managing this. That date doesn't matter as far as reproducible builds are concerned, okay? But as soon as I take files off my machine and stick them in an archive, these dates do matter, right? So again, archive files, tars, jars, wars, whatever. They all have a table of contents, right? And they have dates associated with them. This date basically replaces the file system mechanism, right? So if these dates change, that means the checksum of the whole archive has changed. Okay, so we need to be aware of this. Another example is just random bits inside of your artifact. So I hope you've never done this, but I've heard many stories of people generating random seeds at build time. Those things should probably be done at install time or the first run, some other mechanism like that. Do those things at runtime, not at build time. I've heard stories of people generating security seeds at build time, and then the whole suite of every place that the software has been installed now is the same seed, right? And that's not a secure practice. So anyway, I'm not a GCC user, but apparently there are even some GCC flags that can add some randomness into your build. So things to watch out for. Okay, so moving on to the OS and environment. Okay, so here's a joke. Hopefully no one will take this the wrong way. It's the only context you're ever going to hear me say this, but we're not going to save the environment, right? So we want to make sure our builds are consistent across environments. So I'm a Java guy, right? So my build should work the same on Mac, on Linux, on Windows, or hopefully Windows anyway. For if I'm building jars. Now, if I'm building native binaries, that's going to be different, right? But regardless of the OS you're using, you should have things as consistent as possible. So file encodings, use UTF-8 everywhere. Hopefully, people are starting to move past newer versions of Java. So as of Java 18, I think it was 18, UTF-8 is the default. But my recommendation is still use, just define UTF-8. You don't know who's consuming your software, so it's just easier to just specify your encoding. A couple other things I mentioned already, locales. So locales changed a whole bunch of things other than dates. They changed sort ordering and a whole other thing. So watch out for locale specifics when you do your builds. And of course, I still have files out there on the internet that I've accidentally, DS store files have crept in. So try to get rid of those whenever you see them. All right. Here we go. All right. File input and output order. Okay. So everything needs to have a constant order. So if you have a plugin or a script that you generate or process some data, you need to make sure that data is consistent. Okay. So oftentimes, especially in the Java world, we stick a bunch of stuff in a map, we manipulate it, we do some stuff, and then we serialize it, right? That is not a consistent format, right? That map could, the ordering of that map could be different every time you do it. So you probably need to sort that data or somehow order it before you serialize it. There was a problem in Jandex. I don't know if anyone's heard of Jandex, but it's indexes, annotations, and reflection information for use at runtime. It's a great little library. But one of their older versions, they didn't have consistent ordering for their index format. So this has since been fixed, if I remember right. But it wasn't one of their project goals to make reproducible out format. So, but that means I use their plugin. Now my build wasn't reproducible, right? So we need to make sure the tools that we're using are also generating reproducible artifacts. Okay, so hopefully you're starting to see where I'm going with this. Anything that can change between builds needs to be eliminated. All right, so moving on, how to verify. I talked about this earlier, but you basically take two different jars or two different files, and you run those through a hash function, and you make sure the hashes are the same. Now, this is great if you have the same file, right? You get a binary yes or no. The problem is if things aren't the same, you need to figure out what's different. So there's a great tool called Diffoscope. If you haven't heard of this, I think it's a great tool for many other use cases too. It'll diff ISO files, zip files, directories, a whole bunch of stuff, and it'll give you a nice, pretty format and let you know what's different. It'll diff the table of contents in your jars and zips and archives, so you know if that's the problem or it's the contents. It's very helpful if you're starting to do reproducible builds. I highly recommend it. All right. For Maven Central users, which is probably everybody here, there are a few hundred projects right now in Maven Central that have been marked as reproducible. So there's a whole Reproducible Central project that aims at verifying some of these things. So check that out as well. If you have a project you push to Central and it's not on this list and you think it should be, you can contact the maintainer as well. I'll have a link to this at the end. Okay, so how would you get started, right? So I think one of the first things we do, we need to have stable environments. So how do you do this, right? Maybe you have a build environment that's been defined with Docker or something else, VMs, I don't know. You pick whatever you're going to do. But if we're not going that extreme, you can just make sure everybody's using the same version of Maven or Gradle, right? So you could use a Maven or Gradle wrapper. Make sure you're using the same version of Java. So I like the .sdk SDKman files, which is very similar to the .npm-rc or .rvm-rc type of files. So you know your projects will build the same specific versions of Java. I'm a big fan of these files because they make my local environment the same as my CI environments, right? And obviously every other member of my team. But the basic way to get started here is you run your build twice. So I run a build and then I run another build and I compare the outputs. If those outputs are the same, that's great. But then I'm going to do this on two different machines. I'm going to build two different machines, two different users, and hopefully I still get the same bits. I'm going to compare them, and if I don't, then I know what I need to change. Maven and Gradle both have different ways of defining reproducible builds. So Maven, you basically define a property, and that's basically that's the date that is used in all the archives. This looks a little funny when you first see it. Okay, this date automatically gets updated when you run like Maven the release plugin or versions plugin. So basically you define it in your POM and you never worry about it again. Gradle takes a different approach. Gradle sets a couple properties and then hopefully you never worry about it again there. The difference between the two, Gradle hard codes a date and Maven uses a date that changes. I'm not going to pick a side here, but there are different approaches to solving the same types of problem. All right, so there are a bunch of other benefits too. I think quality is high on the list, so hopefully everyone watching this has tests, right? If my build and my CI system are testing two different sets of bits, that's not good, right? So we want to be testing the same bits. So in order to do that, my builds need to create the same bits. If there's problems with your build or test, it's going to be easier to find if there's not a lot of fluctuation, right? I've worked at some shops that have like a manual testing process where they focus on the things that have changed between releases. So if you work at a place like that, reproducible builds helps reduce some of the noise, so you can compare your old distribution with your new distribution, figure out what's changed, and maybe you can target those areas, or maybe target them a little more than the rest of your test suite. Okay, and of course they're cacheable, right? I think being cacheable is a big one. All right, hopefully everyone knows what I mean when I'm talking about cacheable builds. I'll get back to the JVM world in a minute here, but I think Docker has a great example of cacheable builds that we've probably all seen. So if you run a build in Docker, if you run that build a second time, you will see that the second time you built it, it was very, very fast, right? That's because it just, everything is loaded from cache. Now, in my Docker file I have here, if I change something on the third line, I'm going to take the first 2 lines from cache. So those are going to be almost instant. And then I'm going to actually run the last 3. And that might take a little bit of time, but at least I've saved all the time from that initial apt get, apt install, right? Everyone dreads running one of those. But the effect here is it speeds up my build. Now, coming back to the Java world, I want to point out that a build cache is not the same as a dependency cache. So for Maven folks, right, we're going to download our dependencies. Oftentimes on a corporate network using a Nexus or an Artifactory, right? And then everybody inside that corporate network downloads them from there and they put them in their home directory, right? So your M2 home/repository folder has a whole bunch of jars in it, right? So that's optimizing for network I/O, caching for network I/O. Build caching is different, right? So build cache is typically going to cache the individual tasks or goals that are CPU intensive, namely compilation and testing. Those are the big ones, okay? So Gradle introduced one in build cache in 2017, and Maven has an open source build cache as well. Develocity, the product I work on, also has a build cache that supports Maven, but our server for Develocity supports all of these options, so we don't care which one you use. There are some differences, but at a high level, they're all doing the same thing. Okay. There's also 2 ways to use a build cache. So local and remote. So local is basically just for me. I run a build on my laptop. All the cache entries stay on my laptop. So my next build will be fast for me. And then we have a remote cache. A remote cache is basically populated by your CI, and then my next build, I could potentially download cache entries from the remote cache server, and that speeds up the builds for my whole team. I'll come back to that in a minute. But how does this work at a high level? So you can think of each build action, Gradle tasks, Maven goals, as having a set of inputs, right? Source files, dependencies, compiler versions, whatever other arguments you pass into your compiler. For a given set of inputs, you would expect the exact same set of outputs, right? So if you're compiling, you get a bunch of class files. If you're running tests, you get a test report, maybe some coverage data, right? So what you do is you take those inputs and you run them through a hash function, right? Another hash function, same idea. And you get a key, and you associate that key with basically a zip file of everything that goal created, right? So again, compilation, we're going to zip up a bunch of class files. We're going to store them outside of my build and store them usually in my home directory. Okay, so if I do another clean build and I see the same set of inputs, I can just extract that file, and then my build should be a lot faster. Okay, so let's give a quick example here. Let's pretend I have a 4-module project. Okay, I'm going to have a core module, an export API, and a service that both depend on core, and I have a web app that depends on service. So hopefully you can kind of picture this tree. Without any caching, if I do a clean build, I'm going to build everything, right? Hopefully that doesn't surprise anybody. And then if I were to change something in the export API project, and I run a full build, on my machine, I'm just going to build the export API node, right? Now, that probably isn't super surprising. If I was doing this locally without caching, I would just build the export API and not worry about anything else, right? My CI server is still going to build everything though, right? So with caching, now my CI server knows that it just needs to build the export API. All right, but here's where things get really interesting. Okay, so if I'm going to change an implementation detail of the service module, and the project itself, the service module, is going to get recompiled, but the public API didn't change, so my tests don't need to recompile, right? We did change the code, so I'm going to run check style or whatever my static analysis is, and of course I need to run my tests for that project. Now, the web module, which depends on service, none of that code changed, right? None of the public API changed, so I don't need to rebuild that code. But I do need to run my test, obviously, because my dependencies changed. So now I'm really starting to see some performance, some benefits to build caching, right? I've just skipped a large portion of my build and tests. All right, now coming back to remote build cache. Okay, so we often see about half the benefit of our build cache comes from remote cache. Now, again, local cache, if I do a build and I store something in my local cache, again, I'll automatically, that's great as I'm iterating through my project. But what happens is, I'm going to end my day, say 5 o'clock on the East Coast. I'm going to work with folks in California. They're going to work for a few hours before I come back the next day. And again, folks in Europe are going to start their day out well before I'm going to start my day, right? So they put in a bunch of time. They've made some changes. So the first build of my day is probably going to have a bunch of cache misses, right? Unless I use a remote cache. And then instead of actually having to run the compilation of the test, I can download the cached bits all automatically, and then my build will be much faster. So it speeds up the whole team. All right. Sorry, my throat's getting dry here. All right, so I want to switch gears a little bit and talk about productivity and how these things are related, okay? So there's new research that came out a few years ago that shows that frequent context switching leads to brain fatigue or cognitive fatigue, right? Anyone who's lived through, the last few years of COVID has probably seen a lot of this fatigue as well. But I think this is funny because early in my career, I bragged about being a good multitasker, right? I literally put this on my resume and I would brag about it. I was like, oh, I'm a great multitasker. And in hindsight, that was all bullshit, right? None of that was true. But maybe it looked good on a resume. Maybe it didn't, and everyone else laughed at me and they knew better. But anyway, so this research says it takes about 10 minutes every time you switch tasks to be productive again. Okay, so I'll give you an example here. Let's pretend I have a 15-minute build and I'm working on a feature. And I start the build and I'm gonna, wait 15 minutes, right? Well, I'm not just gonna sit there. I'm gonna go check my email, right? So I'm gonna context switch away, check my email. I'm gonna work on my email for a half an hour or so. And then I'm going to context switch back to my code, right? My build actually failed 2 minutes in. I missed something, some silly test that I wasn't thinking about, whatever it was. I fix it. I start my build again, right? And then I'm going to context switch away back to my email or Slack or whatever it is. And then eventually I'm going to come back and check on my build again, right? So that's potentially 4 context switches just because I have a long build. At least 2, right? Switching away and switching back. They always come in pairs, but potentially 4 realistically, because if my build fails, I need to do something. Or I could go through this pattern all day, okay? I don't know about you, but I would much rather spend my time writing code than dealing with email or whatever else you're doing. All right, so interesting things happen when you focus on fast feedback cycles. So obviously we have less, if your feedback cycles are fast, you have less idle time. Okay, hopefully that's obvious, but that means we're less context switching. Okay, we just talked about that. That's not great. Less context switching, hopefully reduces the cognitive fatigue, right? So we have more focused developers. More focused developers should produce higher quality software. At least that's the goal. Okay, now across the bottom, of course, these are the things I like to point out. So we can have more frequent builds, right? If we're getting fast feedback cycles, that means I can build more often. My change sets can be smaller. Hopefully everyone's doing atomic commits anyway. But if I have a really long feedback cycle, I'm going to cram as much stuff into that build as possible, right? So I'm going to fix the bug that I'm working on. I'm going to, I don't know, update some dependencies and maybe fix a typo or two. Whatever it is, I'm going to get as much stuff in there as possible, and see what I can get away with. But if I have fast feedback cycles, I don't need to do any of that. So my code reviews can be faster, more streamlined. I've had people send me 10-line code reviews before, which are great. And I've also had people send me 10,000-line code reviews before. Which one do you think I did right away? And which one do you think I put off as long as humanly possible? Okay. I literally got one a month ago, maybe 2 months ago. It was 10,000 lines. It was a beautiful change, right? It was a great change, but my brain literally cannot comprehend that many files, right? Or that many changes. It's just a lot. Anyway, it's a long way of saying we can be more efficient now. When things do go wrong, it's faster to fix. All of these benefits are just from fast feedback cycles. All right, so let me know if you've ever heard of the term developer productivity engineering. Okay, I'm guessing most of you haven't. Hopefully, some of you have. But basically, it's an engineering practice that uses straightforward techniques to foster developer success and happiness. Okay, success and happiness. That's pretty great. But DPE emphasizes a few things. So fast feedback cycles, toolchain reliability, right? No more flaky builds, flaky tests, things that fail randomly, and actionable data. So we want to use that data to then improve our productivity, right? But I like to ask this question, okay? Maybe some of you have heard the term developer joy, but let me know if you like to write code in the chat, right? I'm gonna assume most people are gonna give me a thumbs up. Now, the trick part of that question is give me a thumbs down if you don't like to write code at work, right? Most people, I ask this question in person and they'll raise their hand. I love to write code. And then I ask them, do you like to write code at work? And everyone drops their hand, right? And it's because we deal with a lot of frustrations at work, right? So again, there's long builds, flaky tests, just hassle, right? Maybe you have too many meetings. I don't know, whatever it is, it sucks the joy out of these things. So DPE tries to fix this. So I won't go over all of these things. We're getting low on time here, but my career kind of started in the middle here in the early aughts. So there's a big focus on agile and lean, right? The goal was to deliver value to our customers faster, right? But as soon as we uncover one of these problems, or fix one problem, we uncover another one, right? So agile came along, that was great, but then we uncovered how long it took to ship our software, right? So then we see the rise of DevOps, right? Well, the next thing is developers, okay? The slow, painful frustrations that developers deal with is another bottleneck. It's not that we developers are slow, right? It's that we've been dealing with a lot of crap. So again, this is what developer productivity engineering tries to fix. All right, so long build and test cycles are a pain. So I would expect to see in general more tools to help speed up our processes, right? Reproducible builds are picking up steam. I think more projects are focused on ensuring the builds are deterministic. There are some problems though. We're still kind of in the early days. There's no standard way to communicate that your build is reproducible. There's no standard way to define how to reproduce them. And there's no way to communicate if a build has been independently verified, right? Or proof yet. So these things are getting worked out, but still having a reproducible build now is still a big win in my book. A couple more tips I want to leave before I go here. So I would say treat your build like you do any other application. Okay, so keep your bits up to date. Both Maven and Gradle speed up every version. So keep those things updated. Keep your plugins updated. If you have all of your code and your source in a single project or a single module, break those things up. I think that's a big win all around. It helps with caching. It helps running your build in parallel. Speaking of which, you should also make sure you're running your tests in parallel. There's a couple other cool things I like to point out. So predictive test selection. So there's a white paper from Meta or Facebook. Yeah, I know it's Facebook, but it's still some really interesting tech. So I'll have a link to that at the end as well. And test distribution is basically a way to run your tests in parallel and scale past your machine. So I'll have a link to those things at the end too. So all of this is to say security is very important, but it doesn't always need to come at the cost of being productive, right? So hopefully reproducible builds will help balance the scale out between the security needs and the productivity needs. All right. So with that said, I have a few ways that you can get some free stuff. But first, I need you to give me a review on through the JCon World the website, It doesn't have to be a positive review. I would love a positive review, obviously. But if you leave me a non-positive review, let me know what I can do better. I'm going to give this talk again, so I would appreciate feedback. Just giving me the sad face doesn't necessarily help, but I do want to make this talk better. So if you scan this QR code, you'll get a link to my slides, all the resources that I mentioned. There's also 2 ways you can get free stuff from Gradle. We'll send you a t-shirt and socks and stickers if you do our build speed challenge. Basically have an example project and you add caching to it. It's really quick, and we'll mail it to you. And then Influitive, this thing you see here, we have a bunch of challenges and ways that you can learn about DPE. Basically, it's gamified learning. Okay, so you read a chapter of a book, answer a question, you get a bunch of points. We have some really easy challenges, some more difficult challenges, like give a conference talk. But anyway, it's really easy to get enough points for a t-shirt or Lego. As you see here, I'm a big Lego fan, so go check that out, and we'll send you some free stuff. All right, with that all out of the way, it is now time for questions. I think I have a couple minutes here. If there's any questions, put them in the chat. Maybe I can answer them. Maybe I can't. Awesome. Thanks, Mike. And I'm available on social too. So on Twitter, Twitter's kind of dying, but Brian Demers on Twitter, B Demers on GitHub and LinkedIn and all those places. So come find me on the internet. All right. Well, I'm going to assume there's no questions, but I think you can unmute and ask them if you want to. But otherwise, thanks everyone for hanging out and watching my talk.